Dear students, we're now moving over to the next part of transformation geometry. In this section, we'll be concerning ourselves with the topic reflection. Just like translation, when we are dealing with reflection, we have a shape A, B, C, which is reflected about a line, which means this shape will move from where it is originally to occupy another space. In this section, we'll be dealing with reflection, but reflection around two areas. First thing that we'll be dealing with will be reflection about the x-axis. When we are dealing with reflection about the x-axis, there is one simple rule I need for you to remember. And by the way, this is the x-axis, the horizontal line. When we are dealing with reflection about the x-axis, just remember a simple rule. The x values remain the same, the y values become opposite. Now, when I speak about opposite, it means a positive becomes a negative or a negative becomes a positive. Putting this in a mathematical notation, if you are given the coordinates xy, if we have reflection about the x-axis, the coordinates now become x minus y, where the y will simply become the opposite sign. Let's look at the example given. The question, reflect triangle ABC about the x-axis, which means about this axis. Immediately I know that this shape will now appear somewhere along the top here because I'm reflecting about the x-axis. Before I even begin, I'm given a triangle ABC. I need to ascertain what the coordinates are. A is given as coordinates -1, -2, where the x value comes first and then the y value. If I go on further, I have the coordinates of B and I have the coordinates for C. The simple rule that I had applied when dealing with this specific section is xy becomes x minus y. So the first value that I have, or the first vertex, is A, where A is -1, -2. If reflected, A reflected becomes -1, and the -2 now becomes a +2. The value for y changes. Let's look at B. B originally was given as -4, -3. And yes, it is the y value that changes to the opposite sign. And you can see the y value has changed. All x values will remain the same. The last point is point C, which is -3, -1. Again, the y value changes from the y value remains the same. My apologies. The x values remain the same, while the y value changes its sign. See how easy it is to get confused with this. But take your time and you should have no problems. When I'm dealing with the ABC reflected, I now need to go ahead and plot the points for A, B, and C. The value or the coordinates of A is -1, 2. If I go further, the value for B or the coordinates of B is now -4, 3. And if I go ahead and plot the third point, which is the coordinates for C, I get -3, 1. And all I am required to do after this is to join A to B, B to C, and C to A. I now have reflection. Reflection from my original triangle to the reflected triangle. You can distinctly see that if this was a piece of paper and I fold the paper along this line, this shape, the black, will be superimposed above the red, which means it is reflections of each other. I want you to ponder about that for a moment. Normally, if I am given the shape, the trick that I would use here is I will fold the paper along the x-axis. I will demarcate those points or press down using a pen, and you will find that these points will be superimposed, thereby reflection about the x-axis. Before I even go any further to do reflection about the y-axis, give me a few moments just to neaten up what I have. I'm going to remove that, and we're going to go ahead now and look at reflection about the y-axis. If I'm dealing now with reflection about the y-axis, the simple rule that I want you to remember is the y value remains the same while the x value becomes opposite. Again, in mathematical notation, xy now becomes minus xy. And you can see exactly where I am going with this. If I take point A, which was -1, -2, the reflected now becomes 1 minus 2. You will notice that the y remains the same. It is the x value that changes the shape. Now don't worry about this double prime that I have here. I just put it so you'll be able to see the difference between that and the original reflection. If I go to point B was at -4, -3. If I'm using reflection, remember the y value remains the same. It is the x value that changes. And obviously, point C will follow the same subroutine. You will see that this is a very, very easy portion because now I have the reflected points or the transformed points, if you would like to say. I now simply plot them according to the coordinates. Point A is 1 minus 2. Point B is 4, -3. And point C now becomes 3 minus 1. And obviously, all I need to do is join the lines, and you will find that I have the transformed triangle. In this case, it is triangle ABC, which is reflected about the y-axis. And the y-axis is this vertical line. I want you to have a look at the two shapes. You will distinctly see that one shape is a mirror reflection of the other. If I had this on a piece of paper and I folded the paper along the y-axis, the orange triangle would be superimposed above the black triangle. Now in the exams, this won't come out for too many marks. All you simply need to know is either draw the transformed shape or determine the coordinates of the transformed shape. You may now go and do some activity, some questions from the question papers, and understand this section well. Thank you.